Well, here's an interesting engine that came in. I got this at a deal, and I've already disassembled it, most of it. It's basically a Benson steam engine design, which is lower flywheel crank, upper piston barrel and slide. And it's in the Bourne book of Catechism of Steam Engines as a described design from the 1800s. Now, this one wasn't made in the 1800s, but it was made quite a bit later, and it seems to have been made pretty much by hand, maybe from a kit, but as you can see, the machining is really non-existent. He just drilled holes, so it may have been a solid block of brass he worked from, because you can see the size of the piston is quite small compared to the actual diameter of the barrel. There's not much of an undercut either, so I think it was a hand machined barrel for sure, and then drilled and filled to create the air passages. Now, the air passages are clear, but I am going to have to use my milling machine to correct this angled mill here, which I think he gave up on milling once he realized he couldn't do it straight. So I'm going to redo this one and straighten it out. I'm going to redo this one and open it up a bit, as well as this one at the top. And hopefully there's enough of a gap, and an accurate enough gap between the two to correct the timing. So there's the barrel. We'll put that there. And then we have a very crude plate that the barrel was mounted on. So it was basically, let me think, the top was this side. So it was mounted basically like that, but only with 4 bolts. So we're going to make a proper base mounting plate. Maybe make it a little bit fancier, nicer looking. There's the top cap, just a simple slag of metal that was lathed with a rise in the top to look like a steam chest, or steam cap. Then, this is the bottom, which is I don't want to swear, but it's a real nightmare. There's the piston. I put a silicone 3/4 inch O-ring on it. It's too big. So we'll have to probably do a cut piston ring with silicone ring, and make sure that the groove holds it in place. So I'll do an undercut groove to hold the silicone ring in place. This doesn't come off. It was basically running, at this point I realized it was running off mechanical means. It wasn't running off steam, probably ever. Unless they cleaned the inside of the bore and everything, there's no sign of any heat or steam buildup in this engine at all. So you might ask, oh, how are they turning it if it didn't have any steam power? Well, that comes down to a part that was attached to the outside of the flywheel, and that's this huge brass gear. And that would have been attached to a motor, I think, turning it at a slow speed. Now I'll find the slide. Oh, back to the bottom cap. It's been soldered together. This doesn't move. These aren't studs. They're just pegs. And there is no gland at all in there. So I'm going to have to make a gland. I'm going to have to cut these down, unsolder all of this, tap these 2 studs, or drill them and put in 2 studs, and a proper gland nut. I'll use this maybe as a gland nut clamp, and have a cap inside here that is fitting the shaft with a O-ring, silicone O-ring in there. So that's a good afternoon of work, at least. Probably a good afternoon of work. This is probably going to have to go and be remade as well. I have this brass rod that I had previously, because here is the slide. And as you can see, the slide was probably cut with a saw, coping saw, and then rounded off. It's not very square at all. It's completely unsquare, actually. It's a very large chunk of brass, though. Might be able to use it for something else. Maybe take off this fitting here, and, well, we won't use this on this engine. Maybe we'll use this little gland on another engine. But it wasn't moving at all, and it had a very, very bad slide. So let's see here. There's the slide. Basically hand-carved slide. And a very, very crudely machined port. None of this you can see when you're ordering an engine off eBay. But I knew that this had incredible sloppy, crappy fit from the pictures, and I could see that it wasn't that well machined. Fortunately, the eccentric is very, very nice, the eccentric strap, so I think that that was probably pre-made and then modified. We're going to cut this down, and I'll show you how that we're going to do that, because this is completely hand-filed and doesn't really work that well. So, some gaskets that I got from taking it apart, I separated all my bolts and screws into bags so that I have them organized for reassembly if I use them. And there's the connecting part of the rod, which is very, very crude. This would be for the eccentric here. It threads on, but it would have to be corrected completely because it does not have a nice fit on the eccentric arm itself. As you can see, it's quite loose. So, to solve that problem, we're almost through all the parts here. Here's the valve chest cover. And another gasket. Some more screws. Probably 4BA, I think. I've got this fitting here. This is a gas nipple fitting to NPT. I'm going to cut the NPT back on this fitting here. I'm going to use this slide, which is one of my spares from England, and it has an actual properly machined slide valve, and it actually happens to be very close. It doesn't look similar, but this is the gap here, and here is the way that this slide fits in. So the gap is very similar. I'm going to have to take the sides of this slide down about a 1/16 on each side to fit the slide area of the barrel, which you can see here. But if I can give you enough of a shot here. Open, 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 open. It should work if I can mill enough of the slide back to create the same distance, but I'm going to do that after I've fixed everything else on this engine, because the timing will be crucial, and if I make that slide too small, I'll have to make another one. So we want to make sure that we can get it working somewhat with what we're going to put on. Now this is going to be the challenging part. You think that this is tough, but this is going to be the challenging part because it's a little wider. It's just a little bit wider than the original, and the original is not going to be used. So this is going to go on here. There it is with the slide, and I can even pull that slide back and forth nicely without even working it with two hands. So that is going to go there, but as you can see, we have a problem. We have to reduce the outer edge. We have to plug these holes and hard silver solder them with a brass rod, which is this rod here. We're going to turn down the lathe, plug those holes. Then we're going to add a 1/16 on the inside of the edge here, brass piece on each side. We're going to take a 1/16 off the slide, and we're going to solder those sides in so that we will have enough meat to put a bolt through here on the inner edge afterwards. And we're going to put 4 bolts on this one, and we're going to seal it with a probably high heat gasket silicone, maybe a gasket, I'm not sure yet, but that is the solution to this, because that'll give us a nice steam chest look, and it will improve the appearance of the engine as well, because we will have a top cap, inspection cap on the top there, as you can see, make it look a little bit more professional. So there you go. There is a set screw missing from the side of this engine here for a breather, It could be a tap for letting out pressure, like a drain cock at the top. But we'll take a look at this. We can remachine this whole piece if we have to anyways. And that's probably what we're going to have to do. But it will be faster than making a new one. And then we'll get this all back together and see if it actually runs. It was about 100 pounds or so, so it wasn't expensive. It's about that much in parts, I would assume, and brass. And other than having my own slide, if I didn't have my own slide, this would be a lot more challenging, I'm sure. But it is a nice looking engine, and like I said, it appears in the Bourne Book of Steam Catechism as a Benson type engine, and we'll get it running in the next month or so. See what kind of progress we can make. It doesn't have the most advanced bearing blocks, but it's quite a nice base, and I have to assume that the base is a factory cast item. So he might have adapted it from some other kit. If anybody knows what kit this might be from England, let me know. But should be a good challenge. Probably the best challenge yet of all the steam engines that I've rebuilt will be this one. So I am a bit nervous about it, but I have to learn at some point. I also been working on the Sirius engine from scratch, from castings. And a little warning to anybody thinking of getting the Sirius engine for a kit to build as a first time type kit. That would be a pretty brutal mistake. I've got about 10 years of machining, 4 years underneath shop steward, and it's still a very complex machining job to build a Stuart Sirius engine. So you should beware of that. I'll show you some of that work while we're doing it. I have about 26 pieces to make myself. The aircraft machinist is going to make 15 pieces, 13 pieces that I just don't want to be wrong, as well as a new bearing end cap, aftermarket end cap additions, which we'll bolt on. But selling those to people that have made the engine, I've learned from just looking at the drawings and the machining process that their crankshaft alignment would have to be exact to the specs of the drawing for the bearing conversion to work, because if the crankshaft's off even a little bit, the bearings just won't fit when they're bolted onto the outside case, and you would have to open up the holes on the bearings holders, the end caps, to actually position the bearing on the crankshaft, which wouldn't be bad with the gasket and sealant, and Loctite would be okay to use. I don't think it would shift. But the load on the bearing shaft, as well as the bearing, would tend to put stress on these opened up holes that you've used to position the bearing itself. So my engine will be positioned with the bearing exact, and I think that it will probably increase its ability to rev, and I could probably use a high-speed generating engine. Other than that, I think that the kit probably on a 3-inch lathe would be very difficult with a milling machine, and you'd be better off trying to build something like a single cylinder upright, or perhaps a 10H or something like that, because it would be much easier to machine than a Stuart Sirius. The crank web itself on the Stuart Sirius is either you get it, you don't get it. So I would say for every kit that gets built, there's probably 10 to 20 Sirius kits out there in parts scattered across the world that never got built, and just something that really shocked me when I opened it up. They are very complex to make, and that's why they are $600 to $1,000 US on eBay, is because of the amount of work involved in getting them, and the people paying that kind of money are the people who have actually probably tried to make one, or have a good idea of what kind of machining is involved with the Stuart Sirius kit to get to the point where it would run smoothly like mine. So there you go, guys, and the cat says hello. Hey, Bearcat. See you later, guys.